Okay, before we go any further, before I even write down an equation or anything like that, let's look at the right-hand rule. All right. Now I've called up Google. I said, oh, by the way, this is the first thing loading, see? So anyway, the first little 7-minute segment that I just did. All right, so right-hand rule in physics, all right, states that to determine the direction of the magnetic force on a positive moving charge, point the thumb of the right hand in the direction of the velocity, the fingers in the direction of the B field, okay? So you lay your palm flat, and then the force, if it's a positive charge, will be coming out of the palm of your hand, okay? So there you go. That's the right-hand rule. And for some reason, this is very confusing. Because it is. Because we're having to think three-dimensionally, all right? And that gets tricky. So basically, if I have a B field that's going like this, and this will probably be our quiz. This will be our quiz on Monday. All right. I'm going to draw some B fields. Here's our B field. Here's our positive charge flying through here with this velocity. Okay. So I want to figure out the direction of the force because this charge is going to feel the force. Now, so don't believe me? Look at the slide. Slide doesn't tell you shit, but anyway, so look. Notice how it's going perpendicular. It's going perpendicular to both the initial velocity and the B field at the same time. So it's got to be three-dimensional to be able to do that. So look at it. It's going B field, going that way. So here's the deal. This force then, B field's going this way. Aha! B field's going that way. Thumb direction of the velocity. Then that means I put the pin. It's going into the page. And what does the force look like at this point on this charge? What's the force look like? That's into the page. That's the symbol for into the page. You know why? Because if it was going this way, V's going this way, B field's going that way, V's going this way, then that means it's coming out of the palm of my hand. So it's coming at me. This one looks like this. The force looks like this. This force is going in, this force is coming out. You might be going, what? Why is that? Or why is it an X and why is this a point? Because think of an arrow, all right? If I have an arrow, if it's going away from you, you can see the feathers. If it's coming at you, you see the point. All right? So let's try another one. B field like that. And notice everything's perpendicular right now. We'll add that other wrinkle. Okay, so B field's going this way. Let's say the particle is going this way, parallel. What's the force? What's the direction of the force? It's a trick question. There ain't no force. When you do this, so you put your hand down in the direction of the B field, you go, oh, if you close your hand like this, there's no force. Your hand gets closed, your thumb has to come in. Oh, no force. That equals 0. Let's try another one. All right, this time, here's my B field. Here's my uniform B field. What is this? I'll tell you what this is. This is a uniform B field. And what's it doing? It's coming at you. So here's my B field. It's coming at me. All right? I've got a charge now. Positive charge is coming this way. So far, I've just dealt with positive charges, I realize. Okay? So that means B field's in the direction. Okay, I'm going to do it this way. Sorry. Sorry about that. Then I'll stop this. There we go. Okay, so in this drawing, right, that's down here that I put on here, but I can't. All right, hold on. Maybe I can do this. There you go. So in this drawing, I've got the B field going this way, all right, and or the B field's coming at me, and I got the particle going this way. So right-hand rule says B field's going up, particle is going, all right, in this case, so that my picture matches this thing, all right. So I got a B field coming up, the velocity of the particle is going that way, or going that way. So that means, okay, positive charge coming out of the palm of my hand. All right. So in this case, B field would be, the force would look like this. All right. Okay. What about a negative charge? Let's draw the same thing. It's a uniform B field. Okay, so it's a uniform B field. Got a negative charge flying through here with the velocity vector going that way. Do the right-hand rule, and this time, okay, so this time B field's coming up, velocity vector is going that way, but this time the force is coming out of the back of my hand. Okay, force is coming out of the back of my hand. So if I put all this down here, I go, okay, well the B field's coming up, velocity of the vector is going this way, then it's coming out of the back of my hand, so the force looks like this. All right, let's try another one. And then we'll record this, and then then in the next video I'll write down the equation, and we've pretty much got the gist of the first three. This is the gist of it, okay? We do get into the mass spectrometer, which I think is important for you chemistry folks, but here we go. All right, so, and biology, because I've got several students, former students, that biology majors working over at Stowers, and guess what they're messing with? Mass spectrometer. All right, anyway, here we go. Let's say let's try one more. B field going like this, flying through like this. All right, so the B field's going up. B field's going up. Velocity of the charge going that way. So that means I got to put my palm of my hand. Here we go. That means the electric field. Well, again, this is opposite. You're looking at me opposite of what's on the page. If I do it down here, it's coming down. So this force would actually be going into the page. If there's a positive charge, the force be coming out of the page. All right, let's save this.